Disappointed to find out there was no beer here this morning. So a little bit about what an analyst does at Forrester. So I primarily do research, and so about a year and a half ago I started to get interested in what was happening in the industry around application development tools and processes and techniques, and hit upon this concept of continuous delivery. And so that's really been occupied most of my focus for the last year and a half, and continuing to push into doing research around what businesses are doing with this. So I'll share with you a little bit about what we've discovered over the last year and a half or so, and then as Andre mentioned, I'm going to be around the rest of the day, and you'll have an opportunity to ask questions. If we don't have time now, I think we're already a little squeezed on time. Certainly come up anytime during the day, and we're happy to talk to you about what we're seeing in the industry and what trends are happening. So one of the things that is really driving continuous delivery is this business need to respond to customers faster. And so whether it's coming from competitive pressures, whether it's coming from customers themselves being dissatisfied with existing solutions, businesses, and we see both the trends in Europe, Asia, and in North America, that businesses are feeling this pressure to deliver faster. They're prevented from doing so by a variety of different things. So Andre talked about people, process, and tools. And I'd add a fourth part to that, and that's architecture. So a lot of organizations are prevented from delivering faster because of lack of a loosely coupled architecture. But that's potentially a whole different topic. So organizations have to improve. They have to improve the products and services that they're delivering, respond to customers faster. And as we see some of the trends that are happening, one of the things that's farther down on the list but growing in perspective is basically something that maybe most of you are seeing in your businesses as well, that employees coming in, employees are becoming, in a sense, the new competitive landscape for attracting talent, for driving faster delivery. And so as employees come in, they want to work in a different way. They don't want to work in the old sort of waterfall traditional way. And so this is also driving one of the adoptions of faster delivery, because they're coming in with a whole new mindset, a more collaborative mindset. So we're seeing that being a driving factor as well. This example, I'll use it here. I know it's not as applicable in Europe as it is in North America, because we tend to be behind Europe in terms of technology adoption. But as an example, in 2009, USA Bank decided that they needed to have a mobile check deposit capability. And this was largely driven by people serving in the Middle East and basically largely gambling bets and things like that. They trading checks back and forth, and they needed a way to deposit the checks. So they introduced this capability, and most of the rest of the industry looks at it and goes, not that interesting. But as customers start to get exposed to that, they start to get really interested in that. So by 2011, 1 in 4 customers want mobile check deposit. They don't want to have to go into a branch bank or find an ATM in order to get access to the funds in the check. And so and then mobile, the adoption rate's even faster. So by 2012, 65% of customers want this capability and are willing to switch banks to get it. So they're not that sticky in terms of their selection of their banking institution. And so by today, in North America anyway, that this mobile check deposit capability is, you have to have it. If you're in banking, you have to have that capability. We've seen something like a reduction of 3,000 branches being eliminated in North America just over the last year. We expect that trend to continue. So mobile is basically taking over banking, or the consumer end of banking. And so for these banking organizations, many of which have been relatively traditional, they're finding that they have to move to continuous delivery techniques just to keep up with customer demand. So this is just in the mobile space. We're seeing similar things in the cloud application adoption. And this tends to pull the entire rest of the organization along with it, because those mobile applications aren't very interesting unless they can access the customer's bank account, see what the balances are, transfer money between things. So that affects the back-end systems as well. And so all of these things are basically consumer-driven, but it's also competitively driven. So to give a short example, of the complexity of of continuous delivery and why it's important across all different timescales and also all different application types, is that increasingly organizations need to coordinate their applications across many different channels. So they've got changes that happen in social media applications, changes that happen in mobile applications. Those need to be coordinated with the back-end software, at least in terms of providing services. And potentially, these need to work with other partner organizations. So increasingly, applications are assembled from a variety of different sources, a variety of different services, and that's causing organizations to, basically, these change processes are rippling throughout the entire organization. So it's not just happening in mobile, it's not just happening in cloud, but in fact, it's happening to the older applications that have been around for a long time and are not perhaps very well adapted to this continuous delivery model. So initially it's wrapping those things with services and then increasingly changing the underlying infrastructure of the applications. So customers, have this incredibly high demand for new innovation. We're all probably, maybe later today, either watching or missing the Apple iPhone announcements. And so if you think about it, 7 years ago when the iPhone came out, didn't have applications. We didn't even talk much about mobile apps. About a year later or so, the mobile app store comes out. Now you've got an incredible volume of apps on Android, on Apple, on iOS, on Windows. And so organizations have to release across all of these different cycles, not only on mobile, but they've got to coordinate that with cloud. Well, this is data from about a year or so ago. Actually about a year and a half ago now, but the data hasn't changed much. It's shifted a little bit to faster cycles. But you notice that most organizations are struggling to do 2 to 4 mobile app releases a year. Now, as a consumer, most of us would look at that and say, that's not very fast. But if we put our professional hats on, we might say, well, that's incredibly fast. We can't possibly get apps out that fast or get them out monthly. So organizations are sort of increasingly pushed to faster delivery cycles, and as Andre mentioned, this is pulling continuous delivery along at an accelerating pace. So not just, as I said, not just in mobile, but in other technologies as well. And the reason for doing this is that the faster you get feedback, the faster you satisfy those customers, and the better you're able to compete with other competitors. But there's something else that's going on too, is that the faster you can get feedback, the less waste you have. And paradoxically, the less risk you have in releases. And the reason for that is that organizations tend to overbuild software. They tend to oversupply requirements that the customer doesn't really need and doesn't really want, but you can't figure out what those things are until you start getting feedback. And so that overinvestment is one of the key benefits of continuous delivery that doesn't really show up initially on people's radar, but once they start delivering faster, they realize that, wait a minute, we were about to spend a huge amount of time building that thing, and then we find out that nobody actually wants it when you release a little part of it. And so the faster you can get that feedback, the less waste you have. And of course, things cascade out of that. The lower cost, the happier the customer, the less complexity in the applications, and so on. So this faster delivery cycle is not just, it's not just responding to customer needs, but it's also responding to them with the right things that satisfy their needs. So one of the things that I've noticed as I've done research about organizations' adoption of continuous delivery is that the traditional organizational structure is a huge impediment to working more effectively. And the reason for that is that in the traditional organization, we've got very stratified roles. We've got clear separation of responsibilities. We've got business analysts understanding the requirements, and then they hand it off to developers, and they develop some code, and they hand that off to QA, and QA tests it, and they hand that off to operations, and ops deploys it. Well, every one of these handoffs takes more time. You've got basically a loss of information that occurs at each of the handoffs. You've got potentially different artifacts, different ways of communicating, different cultures, different availability, different work queues. So, you know, you need to have somebody build a server for you so you can basically do just dev and testing, and you've got to wait because they're busy working on something else. So those delays multiply, and so as organizations move to continuous delivery, they adopt what we've referred to as a more product-centric model, or some organizations call a more service-centric model, which is basically an integrated team with dev and ops and QA and the business all engaged together, working on basically a single backlog using agile techniques and delivering software in small increments. And so this sort of inverts the organization. Instead of having a very role siloed structure to the organization, we end up having a more collaborative structure, more collaborative team structure that then is supported by different organizational structures. So to bring people together along a particular area of practice, you have a more community practice structure, and that community practice is responsible for things like career development, standardization of skills across teams, and basically connecting people together across teams. So you don't lose the cohesiveness of the profession, but at the same time, you get a more concentrated focus on delivery. And so that changes the structure, it changes the culture, it changes a lot of the way that people are organized in are basically brought together in the organization, and has a tremendous impact on the way you manage the organization. So this is based on a report that I published earlier a couple of months ago. But it basically, there's a different kind of organizational structure when you really push on continuous delivery to the limit. So some of the typical challenges in adopting continuous delivery, and I'll sort of work around this in clockwise order, is that developers have to change their mindset on the way that they develop code. So you don't sit off on a long branch for a long period of time and then merge things together, but rather you're delivering code continuously. So this is basically, you know, working in short branches, sometimes trunk-based development, and every time you deliver, you're doing a build, you're doing test, you're doing integration, you're doing sometimes scalability testing in an automated fashion. In addition, developers aren't isolated from the business. They're constantly working with the business on new ideas and basically sharing things. So some of the research we've done on organizations who have applied this find that developers come up with some of the best ideas about how to satisfy customer needs because they're so intimately connected into how the business works. And then a big change for developers is basically, you know, they maybe traditionally thought of themselves as not doing testing, but now you've got unit tests for everything, and in fact, most of the testing is driven off APIs, and so it's a more developer skill set doing quality assurance, which leads then into quality assurance, is that move to a continuous testing model is a big jump for QA. If they've been used to manual QA, then you know they've got a new skill set to learn, potentially even swapping people in and out, moving, you know, basically getting a more developer-oriented skill set to develop the API tests. Enterprise architecture, or just more software architecture, has more frequent engagement. Architecture really becomes innately part of the application development process as opposed to a separate function. And the architectural testing itself has to become more API-driven so that you get constant feedback on the suitability of the architecture, the fitness for purpose. Ops, you know, we'll talk a lot today, or other people will talk a lot today, about DevOps and the importance of bringing operations together with development to really satisfy the needs of the organization. And so they move to things like provisioning on demand, infrastructure as code, as a way of stabilizing the environments, of preventing the "it works fine in my environment" problem, but also providing faster responsiveness to not only developers and QA in providing those environments, but also the deployment into production. So there's a change in skill set for ops. And as suggested by the earlier slide about the organizational structure, management has a big change to make as well, and this is something that they don't expect. But basically management moves from more of a top-down command and control type of structure to much more of what some organizations call a servant leader model, where they're trying to figure out how to remove obstacles from the delivery teams and how to support them. And so you see this a lot in the book, The Phoenix Project, where there's a real shift in the way that management thinks about and actually acts in supporting teams. And the other measures is that management's been used to measuring based on, are you performing against schedule? Are you performing to plan? And here we're basically planning by executing. And so management's looking at a different set of measures, typically oriented around agile project measures, but also looking at delivery rates, customer feedback, and how satisfied, how are we meeting the objectives of the marketplace? And so then the business then has to be more involved, more actively participating in the delivery process. So this isn't a specify the requirements, go off and then wait for the results to come back. But if you're really delivering continuously, then the business is involved continuously. And so there's a shift eventually to applications no longer support the business, but in fact they are the business. They're fundamental to the business value delivery process. And that's a big change in the way that you structure the business and the way you think about it. But if you're in a fundamentally digital enterprise where you're delivering value to customers through software, then software delivery becomes a really fundamental capability to your success. So a couple of comments about the, I'm just do a quick time check to see how we're tracking on that, okay? So one of the things that happens when you look at the continuous delivery cycle is that most organizations don't start up, they don't go from, let's say, 6-month deliveries or quarterly deliveries to continuous. There's a gradual refinement of their delivery processes and their organizational structure and the tools that they're using to enable that truly continuous delivery. So oftentimes when I talk about continuous delivery, it's more aspirational for an organization. They're not delivering truly continuously like a Amazon or a Netflix or an organization like that, but they might consider to be very fast delivery to be weekly deliveries. But regardless of where you're starting and where you want to end up, this basic process of moving from having an idea all the way through to delivering customer value involves looking at the processes, in a sense using some of the techniques that we've seen from lean manufacturing, where we're looking at an overall value stream and we're looking at the various steps that occur in that value stream and how much time it takes to perform those steps, but also how much time you spend waiting for things to line up, waiting for a resource, waiting for an environment, waiting for a server, waiting for a tester, waiting for a developer, waiting for somebody from the business to give you feedback. All of these things end up introducing delays. And so a lot of continuous delivery or achieving continuous delivery is automating that process as much as possible, but also organizing yourself so that you remove the delays waiting for people to make decisions and streamline that process. So that's one of the reasons why we moved to this kind of team structure, is that it eliminates a lot of the delays and overhead waiting for people to become available. So these techniques from Lean, and you'll see this if you read the Phoenix Project, that it's essentially we're taking those ideas from lean manufacturing and applying them to software and changing the organization to support that kind of process and changing the automation and the tooling to support that kind of process to drive work faster through the system. The other thing that's really key in this is batch size. So this is one thing that comes up repeatedly in the Phoenix Project as well, is that you can't take a huge chunk of work and drive it through this process very efficiently because you have lots of discontinuities and lots of wait time in there. So it's also getting very small units of work and driving it through the system completely, getting feedback on that and then cycling back. And so batch size ends up being hugely important, which is something that takes an organization a while to figure out. And it's largely an application of agile techniques using backlogs or using a continuous flow model like Kanban, but you need that small batch kind of mentality to drive really fast delivery cycles. So a couple of things, typical benefits that organizations get out of this. So there's a concept that you'll hear called infrastructure as code. And basically what infrastructure as code involves is taking the configurations that you'd have for the environments, everything from security settings to how the middleware is configured to what software is installed where to what the users look like. All of those things basically can be described in terms of software, and you can basically version that in a version control system and then use software to build the environments accordingly. So this infrastructure as code ends up being one of the really key enablers of the ops part of continuous delivery. And so a couple of things that come out of that in terms of business benefits. There's a significant reduction in production incidents due to environment configuration errors or configuration drift. And so one organization that I spoke with about this, they did some root cause analysis on their production incidents, and they found that about 18% to 20% of their production incidents were related to non-code errors. In other words, these were configuration error problems. And the cost of those incidents was in many millions, this was a US-based organization, so many millions of dollars per year. And so moving to an infrastructure as code model allowed them to basically completely eliminate those. So there are significant business benefits to each one of these things, but taken collectively, you end up getting even more benefit. So there's reduction in mean time to repair, reduction in time waiting for environments to become available, reduction in production incidents. So there's a huge number of benefits to this infrastructure as code technique. Big batches to small batches is a big thing, and oftentimes people, that's a new term. It comes out of manufacturing. But essentially what we're saying is that you take a relatively small chunk of functionality and drive it all the way through to implement it in production. And so some people sometimes say, well, we can't do that. We can't implement half a payment system. And you can, but what you need to do is decoupling the deployment from the actual turning it on for use. And so feature flagging ends up being an important technique that's used in a small batch kind of delivery mechanism. But what you do is you get feedback on at least the deployment of that capability. You know that the deployment didn't break, you know it's successful, you can turn it on for maybe a selective set of users. And over time what you learn is how to break down the functionality into smaller units of work or smaller batches. The other thing that is counterintuitive from an organizational perspective for many people is that we're all sort of conditioned to this idea that if we're all as busy as possible, then we're all going to be as productive as possible and the business is going to get maximum benefit. But think about the effect on your productivity if you need something critical from somebody else and they're too busy to help you. They're working on something else. So they're fully utilized, but that affects your ability to get something done. And so when you multiply the effect of utilization throughout organizations, you find, and there's a great example in the Phoenix project, there was a key individual that basically was the bottleneck for everybody. It was the key, I think it was Brett, or yeah. So Brett, he's the one who's got to deal with all production incidents, and he's also the one that configures all the environments, and he's the one that knows about all the critical software, and everybody's waiting on Brett. And Brett's one of these people where if Brett ever gets hit by a lorry, then basically the business is going to be in real trouble. Well, part of the problem is that Brett's fully utilized, and they can't basically break themselves of the habit of going to Brett for everything. But gradually, one of the secrets to success in the Phoenix project is basically deconstructing Brett's job and figuring out how to get other people in doing some of those things and eliminate Brett as the bottleneck. But that's, it's a cultural problem for the organization, and it's also a personal problem for Brett because he gets a lot of sort of identity out of being the go-to person for these things. But so breaking down maximizing utilization and looking at maximizing the overall flow for the organization is really the key to success in that part of the organization structure. So that reduces the amount of work in process, again, manufacturing term, but work in process, we all have partially completed work, and then sometimes we get new information that invalidates all that work. We find out that wasn't really what the users wanted, right? Because we build up a lot of work in process before we delivered something to them. So reducing work in process ends up being key, reducing utilization ends up being key, and being willing to have a certain amount of, in a sense, slack time in individuals so you can maximize flow again, counterintuitive. Manual builds to continuous integration, obviously probably a big reason why some of you are here. CI ends up being the engine or the pipeline that drives this overall continuous delivery process. Without that, it's really hard, or I would say impossible, to sustain significant delivery rates without continuous integration. And moving manual testing to being predominantly API-driven is one of the keys to driving this. And then finally, to support that API-driven testing, having loosely coupled architectures. So this largely is the ultimate realization, if you will, of service-oriented architectures, but all the way down to microservices. So everything is expressed in terms of an API, and everything is decoupled as much as possible, or ideally completely, so that you can, rip certain parts of the system out, replace the implementations of that. Nothing else has to change. That provides very high degree of flexibility over time. It also provides significant benefits in API testing, in modularity of the code, in all sorts of other areas. So loose coupling of applications and inside the applications as well ends up being a real key. So to sort of wrap up a few of these things, and then we can open it up for a few questions if we have time. See where we are. Yep, we have a few minutes to do questions. I'll talk a little bit about how all of these things get put together. And so one of my colleagues and I did a report earlier this year, and we called it the 8 Tenets of Faster Application Delivery. And without trying to make it sound overly simplistic, we found that there are actually these 8 things that organizations do that enables them to deliver faster. So first of all, thinking of the delivery pipeline as just that, thinking about what you do as taking an idea from concept all the way through to implementation as quickly as possible ends up being sort of the first mental sort of shift that you make to do this. The second thing is breaking down things into smaller units of work. So for many organizations, this means implementing agile project management practices and starting to work on a backlog and starting to break things down into sprints and using those techniques to deliver software, organizing the teams around that sprint process. Automating the delivery pipeline ends up being key. So it's virtually impossible to really drive an agile project effectively, unless, in my opinion, unless you have continuous integration. Because what happens is that those manual build processes break down pretty quickly. You might be able to do a sprint or two, but as soon as you start to really get consistent with that delivery process, you find that you need CI automation to start driving the rest of the pipeline. So the third thing that starts to come up then is that you find that you can't keep up with the testing. So as you start to implement agile project management practices and start to do, let's say, a 2-week sprint, you very quickly find out you can't do significant levels of manual testing without automation. And here by automation, we mean API-driven automation. So that ends up being sort of the next thing that you end up having to tackle. And then that usually drives you toward a more loosely coupled architecture, because you can't really do API testing unless you have a loosely coupled architecture. Now, you might be able to get your first environment or these test environments up manually initially, but if you're having to recycle the test environments every time you do a build so that you've got a fresh, clean test environment, you're going to have infrastructure as code. So that very quickly comes into the picture. And as you implement these practices, then you get to ultimately a release decision. And one of the companies we talked to, they would talk about having the $1 million meeting or the £1 million meeting. And what they meant by that was that when it came time to decide whether they were ready to release, they would get all these really expensive people in a room, and they go around the room and say, okay, you okay with this? You okay with this? You okay with this? And everybody had to agree that they were ready for the software to be released. Well, that's not a very effective way of making decisions. You really want to make it based on data and based on test results. And so if you've got test results coming out of your continuous testing process, then you know for every build, is it releasable or not? And if it's releasable, why not release it? If you feel confident that you've got sufficient coverage and sufficient quality on the tests. So then that leads you to a final thing of basically automating all of those processes all the way through so that you can do faster delivery. And once you can do that, the business starts to change the way they look at the customer. And they start thinking about running experiments. Well, we don't really know what the right way to reach this particular customer. So let's try a couple of different ways and use things like a more hypothesis-driven development. Maybe we'll do 2 versions and randomly route people to each version and gather results based on that. So the business starts to think more in terms of experimentation and innovation and less about defining all the requirements up front and then checking off the box at the end. And so all of these things then start to reinforce one another as you get to faster and faster delivery cycles. So that basically, these are the patterns that we've seen in organizations of how they've adopted these practices and what the benefits are. So I think I've got a couple of minutes for some questions, if any of you have any. Yes?
How do you apply continuous delivery on a brand new project? So for example, like if you have a capacity field, for example, and you're doing like enhancements every few weeks,
yep.
Then you can apply it definitely.
Yep.
But if it's a brand new project, you know you have to do a big bang. It has to be like 6 months.
Right. Well, there's a concept that Eric Ries has talked about in the Lean Startup called minimum viable product. And so every new thing that you're doing has a sort of a minimum viable level of functionality that has to be there, otherwise it's not interesting. But that can be as small as an individual user story or an individual use case. So you don't have to deliver all the possible use cases. And some of the user stories might be implemented in a less than perfect way because they're infrequently executed. You could live with a few manual processes, perhaps in the back end. So the real key on a new initiative is this minimum viable product idea. Questions? Anybody? Yeah, another one.
How do you overcome that, let's say, the financial hurdle? We're used to planning ahead, getting the budgets ready.
Yeah.
Now we have to do it in a completely different way.
Yeah. And that's true. So the financial difficulties, I didn't really talk about in these slides, but financing this process becomes much more of a continuous model because you don't know exactly what functionality you're going to deliver over the course of the next year, but you do know that you're going to support the business in providing what they need. And so generally, organizations move to a more value-based model that says, well, we expect certain benefits out of this development effort, and we're willing to fund it, let's say, as a percentage of revenues or percentage of overall profit margin, and you establish that sort of pool of funding, and then you fund it like a venture capitalist. You basically say, well, what's the best thing that we can invest in right now, and you shift the money around between different initiatives, depending on where you see the biggest business benefit. So there's a change in funding models. That tends to come relatively late. So I note here that, number 8, the way the business changes the strategy and execution, they need to see that this process will work before they really move to that. So generally speaking, what happens is that you start off with a more traditional funding model where you have to come up with estimates of benefits and you're funded based on that. But then over time, they see the benefit of having a more continuous funding model and gradually shift to that. So organizations that are 3, 4, 5 years into this have generally shifted to that newer funding model and away from the other one, but you generally don't get started there, and that's not so the finance people need data to be convinced, essentially. Question?
Yeah, hi. It's just a question about the infrastructure as code. Is that something, as you said, it's vital as part of CD, but is that something that's the responsibility of the DevOps team? Or, I mean, I know everyone's a developer, but in this model, but if you've got 2 very distinct organisations, one they are the same part of the company, but they're different.
Yeah.
So, you've obviously got to get somebody to go and test all the different configurations of the servers, whatever.
Right.
In your experience, has that been an issue?
It's a huge issue, mostly from what you're describing. It's an organizational issue and it's a cultural issue. Infrastructure as code is really powerful, but basically what it means is that you need to have an ops person with developer experience because they're writing scripts and they're writing code and they're writing things like that, and they may not have that skill set. So DevOps often starts with a an ops person with development experience or a development person with ops experience, and they start working together to figure out how to do this. Eventually it becomes more systematic, but the initial starting point, sometimes it will be literally the developers. They see this limitation, they bring in some infrastructure as code kind of software, start building these things, and then they prove out to dev or to ops that this is really an effective way to do it. But it usually requires somebody on one side or the other to basically take the first step and do some experiments. But I think this is my cue that our question time is up. Anyway, thank you very much. Again, I'm around all day. Thank you.